With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. Now we are going to understand about this question, and our question is assertion and reason based question. So assertion statement is given here. A rise in partial pressure CO2 and hydrogen ion and temperature shift the hydrogen hemoglobin oxygen dissociation curve to rightward. Okay, so let's proceed. And as I read this statement, so we have get an idea about this statement is related to the oxyhemoglobin dissociation curve. Okay, oxyhemoglobin dissociation curve, right? So if we draw a graph of oxyhemoglobin dissociation, so it will be something look like this. Okay, so it is a sigmoidal type curve, and this is showing oxyhemoglobin binding affinity. Okay, this curve showing oxyhemoglobin binding affinity, right? And in y-axis the hemoglobin saturation in percentage, and here is the partial pressure of O2 towards the x-axis. Okay, so this line is showing binding affinity, hemoglobin to oxygen binding affinity. So the various factors and numerous factors are there which affect this binding affinity. Okay, so there are some factors that are temperature, okay, and hydrogen ion, right? And the last one is the partial pressure of CO2 will also affect the oxyhemoglobin binding affinity. So when the condition is favorable, so this curve is lightly move towards the left side. Okay, that means the binding affinity will increase. If binding affinity increase, so the curve moved toward the left side, and when the binding affinity decrease, so this curve is moved towards the right. Okay, so it so this will be clear. Okay, now come to the factors, how the factors are affect the binding affinity. Okay, when the temperature is increasing, so the binding affinity will be decrease. Okay, because low temperature, the oxygen is lightly bind with the hemoglobin. Okay, and due to this the curve will be moved towards the right side. Okay, and when temperature will be low, the binding affinity will also increase as well. Okay, and the curve move towards the right side. Okay, now come to the next one. Next factor is hydrogen ion. These all are the factors. So hydrogen ion is affect this curve, and when the hydrogen ion will increase, the binding affinity will decrease. Okay, and when it will decrease, binding affinity will be increase. Okay, it is also directly proportional to the binding affinity. And partial CO2, partial pressure of CO2 is affect the binding affinity when the CO2 level is increased. Okay, it affect the oxygen binding affinity. Okay, binding affinity will be low, and when the CO2 level is decreasing, so binding affinity will be increasing. Okay, so this will be I hope you this will be clear. Okay, so we can say that the statement first, that is rise in partial pressure CO2, hydrogen ion and temperature, shift the curve towards the right. Okay, so this will be correct. Okay, when temperature is rise, hydrogen ion is rise, the oxyhemoglobin binding affinity dissociation curve towards the right. Okay, so this statement will be true. Okay, now come to the next statement. Next is given rise in partial pressure CO2 or fall in pH decrease oxygen affinity for the hemoglobin. Okay, so this statement also true. As I told you earlier, when partial pressure of CO2 will decrease, it affect the hydrogen ion and it affect the oxyhemoglobin affinity. Okay, decrease the oxygen affinity for hemoglobin. Okay, so this statement is also correct. Now come to the correct option. So option first, that is given if both assertion and reason are true. Okay, and reason is the correctly explanation of assertion. So this option will be true because the reason, assertion and reason both are true, and this reason is correctly explanation of the assertion statement. Okay, so that this option will be our correct answer of this question. Okay, so hope you understand well. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.